Okay, so in the last video that I made was we made that last part of the tooling block, and I had this thought that I might not actually get this video out because I might have figured out my lathe situation before ever needing to use the block. I'm sorry. I'm sorry, okay. I yawned. But actually, I did buy a lathe, and I bought one local. It's pretty big, but we'll talk about that obviously in a different video. I still need the lanyard spacers on the knife, and the lathe doesn't get here till like next Friday, and obviously I probably won't even have it running within the couple days that it gets here. It's very big, so it requires some stuff, you know, wiring and the like. So anyways, so this is what I've got so far off the block, and I spent the last 4 hours getting this post processor somebody had written working, and working for the setup that I'm using. But it is now working, so we will now go over the steps to use said post processor and that tooling block I made. And basically I'm going to link all the stuff that I used in the description, and you're more than welcome to do this as well, obviously. That's why I'm making this video. So first, let's just talk about, I'll show you kind of the setup, and then we'll talk a little bit about the CAD. I think, or the cam, I think it's going to bounce back and forth between CAD and, or cam in real life, because I have to show you how to set it up, and the videos for that explain the post processor never really went over how to set up the tooling in real life on the machine, so this will be helpful for anyone attempting to try this. That was a lot of words. Alright, let's get into it. Okay, here is the very quick rundown of this setup. So basically, this is the tooling block we made in the last two videos. As you can see, I have one tool set up. So I'm going to show you guys how one tool runs, and then we're going to set up the, I got a finisher, and then a part-off tool, and then we have a drill. And so we'll just kind of go over that way you can see me do it, and you can recreate it yourself, and that should help you out a bit. So basically, tools sit in their slots. This is set up for 3/4 inch tools. I think so, yes. These are Mighty Bites. I don't know what they're called, but I'll link them in the description. They're 1/4 20s. That's the bolt size, so that's just the size I'm going to say they are. Very rigid setup. I have it bolted or clamped inside a Kurt DX6, so this will work with the hard jaws still installed, and I didn't know that. I actually thought I was going to have to remove these hard jaws, so that's awesome. Yep, so you just want to make sure this whole thing's nice and flat and level, no chips or anything under it, and then put your tool in, set it up. As far as the spindle goes, let me get what I have set up. Okay, this is the piece of stock we're using. This is a piece of grade 5 titanium. As you can see, it's sitting inside a collet holder, That's just what I had available, so I don't know what to tell you. The stock is sticking 1/2 inch out of the face of this collet. And in Fusion, I set the WCS G54 in this case to be the face of this collet. It's not really G54, but in a lathe post it is G54, but I will go over that in a second. So essentially, every time I want to do a new piece, I'll take this old piece of material out and get my calipers, and I'll measure a 1/2 inch piece and then stick it back in, and you're good to go. What I'm doing is leaving some extra stock in Fusion, and it'll add some extra roughing passes. That way, in case you oversize or undersize, well, mostly oversize, you won't have any crashes. So that's how you handle that. And then, like I said, we're going to set up our next tool, and I will show you guys how to do that. Okay, so you guys are sitting on the X-axis way cover on the left side of the machine. Here are my hands. The door is this way. The tool is obviously facing towards you. This is our finishing cutter. And so I'm going to put this in our second spot here. And we're going to call this second spot in the control G55. So right now, this tool is set to G54 in the control as its location. And G54 is basically the point, the tool tip, the like tangential tip, I guess. Okay, so we got our second tool is now snugged up and square against here. What we're going to do is I'm going to bring the stock in, and we're going to set all our offsets based on the stock. So I'm going to use a 1/4 inch gauge pin, and we're going to basically touch off manually against our piece of stock and do a little bit of math, and that's how we'll get our center lines and all that. So here's our gauge pin. You can also use a dowel pin, an old end mill. You just need to know the diameter of it. And I'm going to bring the stock end. Alright, the first one we're going to do is the y-axis. So in the post-processor, the y-axis is actually turned off. But you need to know where the start of the y-axis is, or where y-axis 0 is in G55, because this is tool G55. So the y-axis value for G54, which is tool 1, is going to be different from G55 because obviously we are in a different spot. So to get the y-axis location for G55, I'm going to bring the stock down in front of our tooltip, and I'm going to slowly bring it in using Y-jog, obviously, a thou at a time and then a tenth at a time. And we're going to slide our gauge pin or whatever you're using in between until it slides freely but doesn't grab the pin. And then we will set G55 part 0 set in the Haas control for the Y-axis. So we're going to bring this in slowly, and I got my pin here. Now you want to be really careful. You only want to slide the pin in and not jog at the same time. You don't want to crush your pin against your carbide tool. It'll cause the carbide tool to explode or chip, and you'll also damage your gauge pin, which is why you should probably use a throwaway gauge pin or a dowel pin. And don't listen to me. So I'm just slowly bringing this in, as you can see, and I'm sliding the dowel pin in between the tool tip and our stock. So now you can see our my gauge pin doesn't want to go in between the tooltip and the stock. So I'm going to bring it out a little bit, a couple thou at a time, until our gauge pin is able to slide in between. So I'm going to bring it back 1 thou, still sliding. Okay, now no matter what I do, it will not go in there. So now that I've done that, I'm going to switch to 10th increments, and I'm going to jog it until our pin no longer goes in there. And as you can see, hopefully my hand's on the way, it doesn't go in there. Don't put too much force sideways because you could still chip your tools, but okay, this looks like perfect here. So now what I'm going to do is, and I'll show you the controller. Now what we're going to do is we're going to go into the work offset page, and under G55, excuse me, we're going to highlight the Y-axis, and we're going to hit part 0 set. So as you can see, that value changed. Now that's all good, but we now need to remove our pin distance. And in this case, so towards our part, and you can see on the control, if we move towards our part, it's going more negative. So because of that, here I'll show you. This is towards our tool holder, and this is away from our tool holder. So because we were moving towards our tool holder and the numbers are getting negative, more negative, we're going to subtract 0.25. So for our 1/4 inch dowel, or 1/4 inch gauge, and it depends on what size you used, and then we're going to hit enter. And I got a warning, you just say yes. Now our y-axis is adjusted for the tooltip, so that means our stock will touch the tooltip at y0. That's great and all, but we actually need y to be center line. So now what you can do is subtract half the diameter of your raw material, your raw stock, and that'll get you to center line. So in this case, our raw material is 0.265. So I'm going to say 0.265 divided by 2, which is, hold on, which is, I'm not very good at math, but it's 0.1325. So in the control, on top of our diameter of our checker, you're going to also subtract or minus, depending on which direction you're going, that half diameter. And like I said, it was minus 0.1325. And you're going to hit enter on the y-axis, and that'll give you your center line for your stock. And to prove that, what we can do is, it's in G54, which is the work offset we're using. You can go, oh sorry, that's not the work offset we're using. Hold on, I'm not sure how to change this. Okay, if you want to change the shown position in your distance to go, basically the position screen, you go to MDI, highlight your manual data, then hit erase program if you have anything, and per the internet you just type in G55, hit enter to actually put it into MDI, then hit the green button and the door is open. That's pretty awesome. Okay, apparently the only way to do this is actually command an X, Y, and an X and Y 0. Please be really careful if you're going to do this, and make sure there's no fixturing in the way of these moves, and I'll always turn the rapids down to 5%. So, now this is showing our Y position at 0, so I'm going to show you guys where Y0 is. So, in position, G55, Y0, you can see that our stock is now center line of our tool, the tool tip. So that's how you find the center line for your part on your tool 2, which in this case, in my case, is G55. Next, what I'm going to do is we're going to touch off an X, and I'm not going to show it, but you do the exact same thing. So I'm going to take my pin, and I'm going to stick it in between our tool tip and our stock, and I'm going to bring the stock over and slowly slide the pin in and out until the pin can no longer go through. And remember not to slide while you're jogging. Only do one at a time. Then I'm going to hit X0, G55 in the offset page, and I'm going to subtract the pin diameter from the offset page, or add, it depends on which direction you're moving. Then I'm going to subtract or add the radius of our stock, which remember is half the diameter, and that'll put us on part center for our X. So I'm going to do that off screen, but that's what I'm going to do, and I'll show you the results. Okay guys, I set our X 0 after doing our Y. This is what it should look like. The X is now centered to the stock, and the Y is centered to the stock. So finally, after you get these two things centered and zeroed out, you're going to finally do your Z height. And in my case, in my setup, the Z height is the face of our chuck, if you will. So I've chosen that because that's just how I've programmed lathes in the past, but you can use the front of your stock as well. So same thing, depending on what you choose in Fusion, and I'll show you how I have it set up in a little bit. Go ahead and do the pin thing between the tool tip and whatever you're choosing for your 0. So I'll do that off camera, and then I'll finally show you what that looks like. Okay, this is Z0 set for G55, our second tool. So as I told you, I'm using the face of that collet chuck as my Z0. So you always want to make sure your stuff is correct and you're subtracting your diameters from your pins. So that is how you set up the tool, and for this setup. There is a way to use your tool setter to automatically do the tool height, but I'm used to setting up lathes like this manually by touching off, and this was just the most reliable way for me to do it. So you can mess with it, but this is how I have it set up. I'm going to go ahead and do the cutoff tool and a drill, but you've already seen everything I'm going to do, so I'm going to just skip over that stuff, and we're going to go ahead and talk about the actual cam setup now. I was thinking while I was dialing this tool in, when you do your XY, and I recommend doing your X first actually, and then your Y. The Z height, you don't need to do the half diameter thing because you're not trying to find center line of your stock. You're just going to the end of wherever your Z is. So just keep that in mind. Don't minus the half diameter. It's only you're only going to minus your pin that you use to check it. So I don't want to cause any weird crashes like that. Okay, so for our last offset, and I'm going to call this one G57. This is a drill, obviously, and drills are not exactly easy to check against a piece of stock. So what you can do is you can put a pin in the collet and check against the pin like that. And I'm actually going to use the probe to probe it in because I'm lazy. So something I did just realize is if you are using something like this and you want to find Z height against the collet face like I'm doing, make sure your drill, the tip of your drill is not wide enough or narrow enough to actually touch this, if you get what I'm saying. If it's too wide, the tip of the drill never touches your thing, so just keep that in mind. It might make it easier just to use the tip of your stock. And yeah, so I'm going to go ahead and set this one in, and then we'll be all set. Okay, got our pin probed in. So that's going to be our G57. And you can see G57, 0, 0. Now for the Z height, you want to make sure you put your drill back in, and then you're using the tip of the drill for your Z height and now your pin, because obviously your height is going to change. So just kind of remember that stuff. Okay, one last thing before the cam thing, I swear. I noticed when I probed the drill in and then I did our Z height, the control said G57, but it wasn't showing the correct Z height like a 0, 0, and I was kind of confused. So when you go to MDI and you type in this G00, I think G00 is either absolute or incremental positioning. Something to do with positioning. So when you do a G00 and then call G57, this should show your correct Z that you just set against the work offset page for G57 or whatever a work offset you decide to use. So if it's showing like a weird number, it's because it's using some other system to display the Z height. So just a pro tip, if you will. Okay, here is the cam for this lathe tooling stuff for the mill. So to start off, this is the part we're going to cut. It's the lanyard spacer for the knives. Very simple, no threading. I don't need to do any threading, so that is up to you to figure out, but hopefully this gives you a nice baseline. So starting off, in the setup, what I was talking about with the Z height against the face of the collet chuck, that's where I have the 0 set basically for this entire operation, is where the stock is sticking out that distance. So in my case, it's the collet face, In your case, you could pick the front of the stock if you want to. Let's see, what else? Your safe Z needs to be higher than the tallest tool you have. So in my case, it's a drill. And at a glance, it looks like 5 inches, so I'm going to say 5 inches. So basically what's going to happen is on a retract, it is going to go 5 inches in the safe direction from your Z reference, of course, right. Chuck, I went ahead and did stock back with a 0, and that's how we got our reference like that. In this is just your obvious normal stuff. Go ahead and I would actually mic your stock and check it, but I got a 0.26. Actually, it's 0.265. I did offset from front, and I gave a 10th thou, so it's going to take an extra pass. This gives you a little bit of wiggle room. This is kind of, you could go bigger or minus depending on how accurate you are. I might go to 1.5 here, and that'll just give us a little more here, in case maybe your bandsaw or something cut one side more than the other, taper, that kind of thing. And then in your post process, your work offset's going to be a number 1 or default, and you can switch this to 1. So that's the setup tab. Of course, that broke everything. Now, the important part is this. This post processor I'm using was made by somebody else, so credit to that person. I'm going to post all the links to their stuff. But the way you set up this work is, first you have your normal tool path, obviously. This is just a simple face. You cannot use constant surface speed on a mill. It won't understand how to read the G-code, I guess. Or maybe the codes aren't in the control to handle it. So you're going to make sure that this is not checked, and you're going to figure out your feeds and speeds like this. And I don't know if this is correct for titanium, but this is just what we're going to give a shot for now. You saw in the previous clips the tool orientation, how I have it set up in the mill with the tooling block on the right side of the spindle and the tools facing on that side. If you flip the orientation, so you have the tool block on the left side and the tools are also on the left side with your spindle being on the right side, so the literal mirror image of what I have set up. When you go to post process, and you're going to obviously use this mill process, you have to select use gang tooling, and that'll flip-flop your X negative or positive. And this took me a while to figure out, but basically in my case, this causes all the X commands to turn into negative X commands, and if you hit no, it's going to cause all your X commands to be positive. Your move commands, basically. Oops. So just keep that in mind. Are you serious? Just keep that in mind for when you go to do this, if you're having issues with it being backwards. The simulation won't show it, but you'll know that it's backwards because it will not cut correctly. Back to the toolpath, we're bouncing around here. 0 orientation, typical toolpath lathe stuff. This you could actually follow a normal lathe guide to do this. So just we don't really need to go over this. What is important is under the tools themselves, you need to go to Edit Tool, and the G55, the G54 through the G57 that we're using is commanded basically through the comment section in your Edit Tool. So our first tool, which you may think of as Tool 1 or in Spot 1, is actually Tool G54 in this case. So in the comment section, you need to have which work offset you set for the tool. In this case, it was G54. Now, for our second tool, which is that finishing tool, go to Edit Tool, Post Processor. This is Tool 2, and it is G55. That is where we did all our work offsetting, G55. So you're going to hit Accept. Now, remember the drill is not, in this case, the drill is G57. So under your comment, you need to have G57. This is what the post is reading to basically get where the tools are in your machine area. And finally, our parting tool is G56. So go to Edit Tool, Post Processor, G56. I don't actually know what this compensation offset is, but that is how that works. And that's actually it. You want to be really careful running this for the first time, and I recommend breaking it up into chunks, and I would go only tool 1 stuff, and then I would go to only tool 2 stuff. Remember, it's your G56 in my case. And then I would go to the drilling and finally the part off. I would do them separately in the beginning with 5% rapid and make sure it works. This is a really easy way to slam your spindle into things because you were obviously working very close to the table. There's your vices and chucks and everything. So just be really careful. So we're going to go ahead and try this, and I'm going to show you how to bump in your finishes. Actually your tolerances. So I need a 201. Oh, yeah. So 201. So this is 9/10 or whatever, or no, 9 thou. But basically these come out to 209 thou. And I'm going to show you how to actually bump it in or out using your offsets. So let's go back to the real world and we'll try this out. One last thing, so this is how you post it. So you're gonna go ahead and right click, post process. They go in the probe results on the control. I just have the spindle speed set to 1,000, but you can set it to whatever. I highly recommend do not go over 5,000, depending on what you're holding your stuff in. But you don't need to treat your mill like a lathe. It's not built to handle the loads in probably the same way that a lathe is, so don't push it like you would push a very heavy-duty lathe. So I'm going nice and slow. These are small parts, so I don't care how long they take. And like I said, for me, I'm using this gang tooling option to flip-flop the X. So I'm going to go ahead and post that. Post it as program 1. And you will see this is what it's going to output. It is using G54, which is in this case, this commented thing here, well, not commented, is basically the tool call. It's calling G54 the tool. And then here, see, it switches to the finisher. That's our tool, G55. The drill is G57. So you can see it's calling these offsets so it knows where to go in space. And on this, you can see I have X negative, but, oops, that's kind of dangerous. X negative, but if you have the gang tooling options switched off, this will be X positive, so just kind of keep that in mind. Okay, and now for the moment we've all been waiting for, which is actually incredibly scary, I will say. So you see it's locked itself to the y-axis, and we're gonna come nice and slow, 5% rapids. We're going to make sure in our distance to go that we have plenty of room. So we look good. I'll go ahead and turn the coolant back on, and now it's going to do a simple face. So it's going to retract to our 5 inches. And now we're going to do our roughing on the outside profile. Alright, now it's going to chamfer. And that's pretty dangerous. See, it just moved straight across to go to our finisher, and it didn't even retract, so stuff you want to be really careful about. I wonder if it's going to do that when it goes to drill. So we're going to be really careful about it not retracting. Okay, so for some reason it's decided it will now retract. So it's going to move to our drill and hopefully not explode. It might have left a nipple on the first face, so hopefully the drill survives. Hopefully it actually retracts out of the drill. Okay, so now it's going to lock itself back to Y, go to that retract plane, and hopefully not explode on part off. Looking good so far. This might get a little loud. And we'll probably lose the part too, which is something I'm kind of not really sure how I'm going to handle. Oh, that was actually really quiet. Okay, so success, minus that really scary transition move between the roughing and finishing. So as you can see, the part is now gone, and I now need to find it, which is super. So let me find it. Alright, so this is what I found. That's the part. I think the finishing tool is not set. Here's our little side. Is not set correctly as far as in this case it's X direction. So I'm gonna measure this. It's supposed to be 209 thou, and I usually just shoot for 2.1. So I got 212 and 4/10. See if you guys see that. There you go. So this is basically saying we're off by 3 thou, 3.5 thou. So what we'll do is we don't need to retouch our stock, and we're just gonna move. Sorry, I thought I had visitors. Okay, so we're just gonna bump our X offset in the control for our finishing tool. You probably don't need to change your roughing tool because it should be leaving stock, so I kind of just leave that. You might want to change the first tool if it's facing to 0 with no stock to leave, because if the height is wrong, you can change it with that, or you can also change the Z distance for your parting tool. So that's two ways you can control your part length. But first we're going to try our X. We're obviously going to bump the X towards the part 3.5 thou, because I think you can do full. It's not like radiused, I don't think. I don't know, we will find out. And let me cut another one. It's pretty easy. We'll obviously just take the collet chuck back out of the machine, load up another piece, and use the calipers to do 0.5 away, which is how I have it set up. That way I don't need to retouch off Z heights. That's why you have those roughing passes. So let me cut another one, and then we'll see if that works. Okay, so I'm going to end this here because I think this is already really long. So I got this guy. That's correct. It's kind of hard to see that focus this. So you may notice that there's a bump in the middle. It's actually supposed to be a dish, and I'm trying to figure out why that would be, why. It's the wrong way, obviously, so probably just need to flip-flop something, but hopefully this gives you enough info for actually, if you wanted to do this yourself for some reason. But sometimes you gotta do what you gotta do, you know? So, yeah, let's see. That's pretty much it. Stuff in the description. I hope I put the stuff in the description that you're looking for. Let's see. Video on the new lathe, that's coming when the new lathe gets here. Should be next week, Thursday or Friday. It's kind of heavy. And yeah, it should be interesting fitting it in here. It's 28 feet long, conveyor to bar loader. So, yeah, rigging costs are, they're expensive. Anyways, thanks for watching, and catch you on the next one.